Okay. These are a set of types of numbers. We have different types of numbers in maths, right? So numbers generally are divided into two. It's either the number is what now is real, or the number is what now imaginary or complex, right? Real numbers or complex imaginary numbers, right? We have real numbers and then we have what now complex or imaginary what numbers. Is that okay? Now what makes a number real? The number what now exists. This one they do not what now do not exist. I will explain what imaginary numbers are with time, right? Then for rational numbers, any number you can write as a fraction, where the numerator is a whole number, denominator is a whole number, you have what now? A rational number. You can write it as A over B, where A is a whole number and B is what now? A whole number. As long as you can write the number as a fraction, is what? A rational what? Number. If you cannot write the number as a rational number, as a fraction, cannot be written as fraction. I mean common fraction now, because we have different type of fraction. Common fraction I'm talking about here now, right? You can write as a whole number of another whole number. We call it what now? Irrational what? Numbers. I'll explain all this in details with time, right? Then, what is an integer? Simply, an integer is either a positive whole number, a negative whole number, or what now? Including zero, right? So generally, sometimes the word integer, have you heard the word integral before? Or when you've heard about integrity? The thing that somebody has integrity. The word integrity came from what now? From integer. It means that the person is a complete human being, is a whole person. And when you're talking about integrity, it means that what the person is what the person does, and it's what the person what now says. You know, there are people that they will say one thing, they will do another one, and I don't know if you understand what I'm trying to say. If who you are and what you do and what you say is the same, we say you have what now? Integrity. That's wholeness. Are you get what I'm saying? So for integers simply are what? Whole numbers. Can you say whole numbers? Whole numbers. Integers means what now? Whole numbers. Right? Whole numbers. So integers are what now? Are whole numbers. And then you should know that whole numbers can be what? Positive. And they can also be what now? Negative. Including zero. Is that okay? Is that right? What are natural numbers? Natural numbers are numbers that everyone that is growing tends to be acquainted with. Numbers that you learn. Or I can just simply say that what they are positive what? Integers. You cannot go and tell your grandmother to tell you what -7 is, because she knows what -7 is. Except she's education, she will not know. You get what I'm saying? You cannot go and tell a child that is in grade 1 or a child that's in primary 5 or primary 2 that she should do -28. They won't understand that. Or you go to a child that's in KG and telling the child what now? That there's a number called -9 or -8. Are you get what I'm saying? They are natural numbers because they are numbers that people generally are acquainted with. And simply, natural numbers are positive integers. They are simply positive what now? Integers. Is that okay? Now I'm going to run through them and give you examples as quickly as possible. Is that right? Okay. For complex numbers, right? I'll just give you like 3 examples. Even your calculator will not be able to decipher the number. Will not be able to make sense out of the number. The square root of all negative numbers. We know that the square root of 16 is what? Is plus or minus 4, right? Yeah. But the square root of -16, your calculator can never give you the answer. Try and see. Quickly and tell me. You don't have to.
Square root.
The square root of -16. The square root of all negative numbers do not exist. There's no square root for a negative number.
Is there math error?
Do you understand that? That's just one example of what now? Of complex numbers. Several. The word rational is an extension of what now? Ratio. If you have heard of ratio before, right? So when I tell you 2/7, in one particular kind of mathematics, you can do it as 2 what now? Is to 7. For every 7 that this one has what now? 2. You get what I'm saying? So anytime you can write numbers as ratio, right? Whole number of another whole number, you have what now? A rational what? Number or as a fraction. Is that okay? Now if I have something like the square root of what? Square root of 3. There's no way I can write the square root of 3 as a whole number of another what now? Whole number. In fact, most square roots are not perfect squares. they're what now? Irrational numbers. When we're talking about sorts, I'll talk more details about what now? Irrational numbers. Is that okay? And then one other thing I want to emphasize before we go on is that for one of the ways you can easily tell that a number is rational is if it has a terminating decimal. Terminating decimal, or it has a recurring decimal. Any number that has a terminating decimal, any fraction that has a terminating decimal and a what now? And recurring decimal. Any number at all, right? Fraction rather, sorry. It's going to give you what? A rational number. Like I said, all this I'll explain. We'll get to what now? Relevant topics, right? What are the fractions? I'll explain all this. Is that okay? Okay. I want to talk about factors first before I go to stuff like even number, odd numbers and all that, because these are important to understand, especially factors, not even multiples, right? What's the factor of a number? For example, the factors of 12 are what now? They are 1, 2, 3, 4, 6, and what? 12. Why? Because all these numbers can divide 12 without what now? Remainder. So the factor of a number can divide the number without what now? Remainder. If I ask you for the factor of, let's say, 20, the factors will be 1, 2, 4, 5, 10, and what? And 20. Because all these numbers can divide 20 without what now? Remainder. Is that okay? I'll come back to talk about factors, but let's just get the explanation from here. Then what are multiples? Multiples are actually the inverse of what now? Of factors. I showed you that yesterday when doing division, right? Yeah. If I'm asking for the multiples of 12, I'm looking for numbers that 12 can divide without what now? Remainder. So instead of the biggest factor of 12 is what now? Is 12? The smallest multiple of 12 is what? Is 12. So the first multiple of 12 is what? 12 times 1 is 12. Yeah. 12 times 2 is what? 24. Times 3 is what? 36. Is what? 48. Is what? 60. And it goes on and on. Multiples they don't work now, they don't finish. You get what I'm saying? So why what now? Why we can exhaust factors? We cannot exhaust what now? Multiples of numbers. You get what I'm saying? They go on and on. You get what I'm saying? So if I'm doing what now? Multiples of 20, it'll be what now? 20, 40, 60, 80, 100, and it goes on and what now? And on. Is that okay? Is that right? Okay, I want to give you an example that you may remember for a very long time. If I say that Chris, right? If Chris is for Chris and Maruna, who do you think is going to be multiple? Multiple is what now? Maruna. And then what now? Chris is what? So if I said Chris is a factor of what? Of Maruna. What am I saying? Chris can divide Maruna without what? Remaining. Yeah. Do you understand? Yeah. And if Chris is a factor of Maruna, that means Maruna is what now? A multiple of what? Of Chris. You get what I'm saying? Yeah. Do you understand? Yeah. Even numbers are numbers that can be divided by 2 without what now? Remainder. Please take note of this code I'm giving to you. 0, 2, 4, 6, and 8, right? 0, 2, 4, 6, or what now? Or 8. Boom. Take note of that. Right? Because this will always help you to know what now? Even numbers. All even numbers will end on this side of what now? By that. You get what I'm saying? The last value on this end for even numbers are what now? Will have this code. Is that right? The value under the unit will either be 0, 2, 4, 6, or 8 for the number to be an even what now? Number. If I give you something like 2, 5, 9, 6, 7, 3, 8, 1, 6, 7, there's no need to stress yourself. If you want to know that this number is even or odd, what do? You check for what now? The last digit. You get what I'm saying? Yeah. So this is not even number? No, it's not. But if I take away this 7, it becomes what now? Even. Because 6 is here and 6 is here. Is that right? If I do this now, it's still what now? Even number. I get this. If I do it like this, it's what now? It's no longer even. So you just what I'm trying to say. Yeah. If it's not having this, then it's going to be an odd number. As a whole number, is that right? Yeah. Okay, for even numbers, right? Sorry, we're already through even numbers, only odd numbers, right? Like, if the number is not even and it's a whole number, definitely don't know what now? Odd. So they cannot be divided by what now? By 2 without what? Remainder. And then for their own code, I'll have 1, 3, 5, 7, or what? Or 9. If they end with these values, it means they're what now? They're odd. Is that right? Mm-hmm. Yeah. What makes it a prime number? It has only 2 ordinary factors. We already know what factors are, right? Any number that the factor is 2, that number is what? It's an even number. If 2 is not a factor, it's what now? An odd number. If the number has only 2 factors, the number is what now? Prime. You get it? And prime numbers are the most important numbers in mathematics. Take note of that. It's just like the prime minister is the most important of all the ministers, right? Yes. If with time I'll show you so many things that you can do with what now? With prime numbers. Are you getting it? So what's the first prime number? The first prime number is what?
Yes.
It's 2. 1 is not a prime number because 1 has only one factor. The only number that can divide 1 is what now? Is 1. The only number that can divide, numbers that can divide 2 is 1 and what? 2. 3, 1 and what? 3, 5, 1 and what? 5. 4 is not the prime number because it has more than what? More than 2 factors. You got what I'm saying? 6 is not because what now? In fact, 6 has 4 factors. You got what I'm saying? If there are only 2 factors, it's going to be what now? A prime number. So I'll give you the first, the prime numbers between 1 and 50. There are about 15 of them. Is that okay? What I have now, these are the first 15 prime numbers. Actually, prime numbers less than 50. Are you with me? We have 2, 3, 5. All these numbers that you're seeing here now, right? They can only be divided by what now? 1 and themselves, right? The only thing that can divide 37 is 1 and what? 37. Likewise for the others. You understand what I'm saying? So all prime numbers have how many factors? 2 factors. Is that right?